The ultimate aim of GNSS testing is to evaluate and optimize how a GNSS receiver works in the real world. To gain actionable results, that testing must include a high degree of control and repeatability, conditions that cannot be met in the real world. This means lab testing, but lab testing is not real. Bridging that gap between the lab and the real world, what we call realism, could be a key driver in helping developers to save time, save money, and generate more actionable data for a greater proportion of their testing by bringing that testing into the lab. When we talk about realism in GNSS testing, we're talking about four key areas: the transmitters, GNSS satellites, their antennas, clocks, trajectories, the signals they emit, the propagation channel, the GNSS signals journey from the satellite to the receiver, including the atmosphere and the local environment, the receiving antenna and hardware GNSS receiver, and the structure and dynamics of vehicles carrying the receiving antenna and GNSS receiver, whether a car, spacecraft, or a person. The more these areas are addressed and improved, the greater the degree of realism in the test. As can be seen here at WMG at the University of Warwick, there are a few key steps developers can take to enhance their environments. These all start with considering and understanding the test equipment. GNSS simulators are powerful tools and are critical in product development, but a poorly designed simulator can introduce effects such as power instability and phase noise, whether through badly insulated circuitry or an inferior oscillator, compromising both the realism and the integrity of the tests. These considerations are also critical in designing high-quality record and playback solutions where flaws in design can lead to critical failure in the reproduction of the real-world environment. From here, developers can introduce models that enhance the realism of each domain of their test environment, from utilizing real-world ephemeris data to detailed reproduction of ionospheric effects, to realistic 3D modeling of the local environment, and onto data-led modeling of vehicle dynamics and receiver effects. The real world cannot be fully recreated in the lab. There are too many variables to account for, but Spirent is helping its customers get as close as possible, combining the pinnacle of performance, fidelity, and reliability with models and techniques that are enhancing its customers' GNSS testing.